Next, we have two pals of mine from the Pittsburgh Supercomputing Center, guys that I've known for a long time. We suffered together through the TerraGrid project and continue to suffer with the Exceed project. No, I'm sorry, it's a terrific project. Suffering is all relative. Right. Is it just you or Brian? Okay, so the speaker's J. Ray Scott. He's a Senior Director of Facilities Technology at the Pittsburgh Supercomputing Center. His staff is responsible for computing, networking, and storage technologies. He's a great guy and a personal friend of Slash. The non-speaker who will be doing the Q&A is Brian Johanson. He's been an HPC system administrator at Pittsburgh Supercomputing Center for the past 17 years. He has managed Lustre file systems on the last 3 PSC supercomputers. He's a system and Lustre administrator for the PSC's latest system, Bridges. He has also been on a boat. Ladies and gentlemen, J. Ray Scott.
Thank you very much, Steve. It is good to be back. I enjoyed your opening comments. I've missed these meetings for about 5 years. Listening to your opening comments, I plan to return in 5 years. Yeah, and I need one more. I'm Ray Scott. I'm doing the talk. We figured Steve would be able to learn how to pronounce my name with minimal trouble. So I am joined with Brian Johanson, and as his introduction said, Brian is the system administrator for Lustre and for our new system that I'll be talking about. And as Steve would, so Brian does all the real work. I give the talks. So as Steve would say, I'm the manager. Okay, just a little bit about the Pittsburgh Supercomputing Center. We're administratively a part of Carnegie Mellon University. We're a joint effort between the 2 big research universities in Pittsburgh, Carnegie Mellon and the University of Pittsburgh. This year is our 30th anniversary. We're having a lot of birthday celebrations for that. And we receive support from a lot of different areas in the government and the industry. Our primary support and support for the system that I'll be talking about today comes from the National Science Foundation. The system does come to us through an award, a $10 million award from the NSF and a program that's mentioned there. If this meeting had an award for the timeliest talk, I think we'd be in hot contention for it. The system is just coming out of its acceptance test for stability. We finished that 48 hours ago, and we're starting a user test now for a couple weeks, and then we'll be opening it up for production. So what I'll be talking about is certainly information that we had a tough time getting in by the deadline for the talks. So I'll try to give you a couple updates, but there will be more developing information, and we welcome your contact if you'd like to keep track of how we're doing. During the acceptance, I mean, the end of the story, I like to sort of tell the end of the story first, and that way people can awake refreshed at the end of my talk. Over the last month, we've been running about 40,000 test jobs through the system, test jobs using Lustre, and of course, being a stability test, they all had to pass, which they did. And so we've been pretty happy with the system and the components, and that's what I'll be telling you about. When you get these awards, you get to name the system. We're a bunch of Western Pennsylvania folk, and so we called it Bridges. The Pittsburgh Visitor Bureau says that there are more bridges in Pittsburgh than any other city in the world, beating Venice, Italy by, I think, 3 bridges, they said. So that's why we named it. As Steve mentioned, this system will be a part of another national program sponsored by the National Science Foundation, Exceed. A couple meetings ago, Rick Wagner talked to you about the Comet system and at the San Diego Supercomputer Center. So the Bridges system will join Comet along with Wrangler at TAC and Jetstream at Indiana as new systems in Exceed and then available to the national science user community. And as it says here, the Exceed is a consortium, so while we do compete for the awards to build these systems, once awarded and then brought into production, each system has a different complexion, so our goals as we go into production are to complement each other. So as we get users onto this system, what we're really trying for is big data, machine learning, some of the, what many people think is maybe the non-traditional HPC. So as I go through describing the system, you'll see that this is not just a large MPI machine. There are other systems in the Exceed program that are good for that. I think what I like the most about the Exceed program is users do have the ability to move from system to system. So if we get a user on our system who is particularly obnoxious and complains a lot, I just tell them they'd be much happier on Comet, and I send them to Rick, and he takes good care of them for me. Okay, so on to the system itself. We have several technology partners. I'm proud that 3 of these are sponsors of the meeting and echo what Steve says about the importance of the sponsorship. Hewlett-Packard provides the compute servers, and then they were the main integrator for us. NVIDIA, we have a small number of GPUs available. Again, as it's a big data machine, a lot of the machine learning people these days are using GPUs, so we'll be bringing in some of them for that. And then Intel has been a real close partner. Of course, the CPU technology, also the new interconnect that they have, the OmniPath architecture, which I will soon start saying as OPA. So when I say OPA, that's OmniPath architecture. And then, of course, tightly coupled to that, the Lustre file system. All of the storage, the compute servers are all from HP. All of the storage, disks, JBOD shelves, and servers are from Supermicro. So I don't want to spend too much time on sort of the misery that we've had in the last year or 2 months. But we did start out with several issues when we were trying to stitch together the servers, the OmniPath Interconnect, and then put Lustre on it. The graph there shows, if you can see there's a faint blue line at the bottom, was our LNet performance, and it was pretty low. It was around, I think, 7 gigabytes a second. Worked with Intel, came up with workarounds, and by applying those, got ourselves up to 10 gigabytes a second pretty quickly. And we saw our share of bugs and oops crashes as well. We've moved past these, so that's why I don't want to spend too much time here on, if you were to start now and pick up the latest codes, everything that we have encountered is pretty much fixed at this point, so you'd have smoother sailing. So a little bit about the OmniPath itself. The Intel people are here, they have their table. They'll be more than happy to talk to you about the real low-level details, so I'll skip those in the deference of time. But just what I did was I put together this list of things that we liked about OmniPath. I would say in no particular order, but it is the order I wrote it down, so subliminally there's probably a bias in here of what we thought was important. In the pictures there is the 48-port switch and also the PCIe card that you plug into the servers. So the first thing that we did like, it's a high radix switch, so it's 48-port, lets us use fewer switches, lower cable lengths, things like that. So that was an important part for us, and again, a very high-speed HBA or HFI, host fabric interface. If I was to throw cautions out here to try to help the crowd or those that might follow, these are very high-performance cards. You do need PCIe Gen 3 by 16. If you have designs on a server, while I got these 16 servers in the back room, I'm going to make those onto OPA. If you've had them for a really long time, you might have some trouble. Really long time is like 6 months. So you have to make sure, even just at firmware and update levels, many of the servers need an update to run this. Again, problems that we're all past, but just a little warning there. The other thing that we liked, the OmniPath is 100 gigabit per second. Everybody can read that. Everybody knows about that. What we really liked was the injection rate. So it has a very high injection rate, 160 million messages a second on MPI. As I mentioned, we're not really building an MPI machine, although we will have some MPI applications. So we thought that was a real feature of OmniPath. And then the quality of service, and I mentioned at the beginning, this is all a work in progress. We're trying to have a very timely talk, and if there was one reason, I'm sure every speaker could say, I wish I had another month, but if there was one reason why we would have liked to have had another month before doing the talk, the quality of service features in OmniPath appear to be very good. We've started to try them out a little bit, and what we want to do over time is have a quality of service for MPI and then a quality of service for Lustre traffic. And if people are doing MPI, Lustre should get out of the way, but if they aren't, we should still get the full service. So that's a work in progress, is to turn on the flow management and see how that works. We have seen very good performance right out of the box. Again, due to time, we've had almost no time for liked all the work that the Dresden people described. I hope that we get to do some of that fine detail testing as well. So far, we've pretty much just thrown it together. And then the last three are on the software support, which has been very good for us. First, it's all Open Fabrics compatible. And then what we really loved was it has LNet support, so Lustre runs right over top of the OPA fabric. And then also the IP, TCP IP support as well. So they do support IP over OP. And they don't want us to use that acronym, but it works very well. So with those three features, we've been able to move pretty much all of our software off of existing systems over to this, just move it right over and have it work out of the box. A lot of good management features come with OmniPath. I will let the Intel people describe those to you. You get a lot of nice dashboards. We kind of like this one. We own 835 servers in this system, and so there on the dashboard shows we have 835 nodes up and working on the OmniPath. So you get a lot of good information. Of course, all of this also available through command line tools. Using these kind of tools, the installation went very fast, even able to detect cable problems. It's easy to detect like a completely busted cable, but the installation team was detecting cables that were degrading by 10% and then replacing them with good cables. So lots of good tools, which I think will help us over the long run. So the topology that we're using in bridges, it's a little different because, again, we're not building a machine that is dedicated to all MPI traffic. Instead of one job on the whole machine, we expect to have perhaps hundreds of jobs using subsets of the machine. And so we have greatly thinned the topology from what you might think of, in a more traditional fat tree MPI machine. We're using the same 48-port switches everywhere in what we're calling the core area, where Intel might have liked us to use some, big high-density director switch. We're just using 6 of the 48-port switches, and then feeding those with switches at the leafs in the racks. So we have 42 nodes coming into a switch, and then 6 uplinks to the core switch. And then the core switches themselves form a star or a fully connected mesh. Again, if you were doing an MPI machine, you might like to increase the cross-section bandwidth by going to a director, but for what we needed, doing it with these core switches was good. In our first configuration, we had, and we designed, it says, the PSC original mesh. We designed this upper level mesh, took it to Intel. They have a nice simulator that they used, spotted some problems with 5 switches, and so that's how we ended up with 6 switches with their help. So the compute nodes at the bottom there will come up through a switch, and then everybody will talk to a core switch. Also connected to the core switch, as you can see, the OSSs, the MDS, so that's where Lustre will sit. So everybody will have 2, but no more than 2 hops through the switches to get to the to Lustre. We did write a video game. If you want more details, I didn't want to get into all of the cores and Intel part numbers. So if you go to that URL or just track it through the PSC homepage, it's an interactive tour of the whole system. And this is exactly what it looks like on our machine room floor. It's really stunning to see. So if you mouse over and click on the components, it gives you the details of the part types and performance counts and things like that. But the lines are the OmniPath, and then there's the different components. The Lustre file system are the white, the cubes. The white cubes are the servers, and then the white disks above them. Okay, so the layout, again, I'm going to move through this quickly. It's sort of traditional, and also the slides will be in the deck. So for each OSS, we have dual port SAS cards, 4 of those. That fans out then to 4 Supermicro shelves, and the traditional Supermicro 44 bay front and back shelf, and then an OmniPath card coming in. I think that what I wanted to point out here was the graph at the bottom where we looked at the data paths, and we have the maximum gigabytes, the peak, you know, the rating on the wire. And so if we look at the server components, the drives, the PCI bus, and the SAS, we see those are pretty well balanced, sort of floating around the high 20s to low 30 gigabytes a second. And that's good, because then the OmniPath sitting at its 12 gigabytes means that the server will never be the bottleneck. And that's fine, because the OmniPath is shiny and expensive, and you don't want to hold that up with the server. We might have tried to pull those lines in a little bit so we don't overwhelm the OmniPath, but for capacity reasons, we did want to have a little more storage, so we pushed those lines out. Okay, and then the MDS, again, we're not at a stage yet where we're doing HA. We have the hardware set up to do that. We're certainly looking at the D&E work and moving forward on that, but this again we're in the early stages. So we have the traditional sharing infrastructure. We just haven't really implemented that. Okay, on the software then, and this is, I say, we've been working this sort of hour by hour. We were, you know, loading kernel modules, changing PowerPoint, load kernel runs, change PowerPoint. So we did end up with this software configuration. You can read there. We started with release candidate 5, and literally the night that we finished, we got Peter's email about 2.8's available. So we were using, I think RC5 was 2.8, the same thing. So we were using that with really no problems. We did start to see one problem. We put a patch in Monday night while we were here. I usually don't like to do things like that, you know, change system software with people not in town, but hey, we're better to do it, you know. If it hadn't worked, that would have been my talk, okay? It's like, hey, why didn't this work? We're also doing ZFS, almost the latest ZFS release. It's still, as everybody, the talk that we had on the opening day about packaging is still a little bit of a puzzle to put this together, but we have gotten it to hang together and to work well. So, and it says we have 16 RAID Z2 pools on each OSS, and then on the MDS, we're ZFS striping the SSD drives. The colors, the idea, you can look at them more closely. The only reason I put that chart up is we've split up the pools. What you want to take away is on that chart, the color, apologize to the colorblind, there's no place on there where there's more than 2 disks of the same color in the same shelf. And so with the RAID Z2, we can lose the shelf half and still be functional. So this is why you came. The performance that we've been able to get to date, again, with pretty much no tuning. So on OBD filter, we've been able to get into those OSSs the 16 gigabytes a second. Now, if you recall back to my other slide, the hardware at its weakest point, which is the disks, was capable of about 26 gigabytes a second. So as a manager, I'm happy it works at all. The systems and the rest of the group we might like to see that go up a little bit, but getting 16 gigabytes a second with the software stack on there out of a possible peak 26 gigabytes a second, I think we're doing really well. It doesn't matter because we'll mess the whole thing up in a little bit by putting users on anyway. So, I'm sorry, that was the write performance. The read performance, again, 10 gigabytes a second. We're obviously would like to see that go up some, although at 10 gigabytes a second, we're still matching the OmniPath. So we're not sort of holding that back, but we'd still like to see if there isn't something we could do about the read performance. Again, these are OBD filter numbers running right on the OSS. Okay, and then for our client performance, so this is the, maybe one more drum roll. This is where we end up is, thank you, is for the reads, we were at 20 gigabytes a second. That's with 2 OSSs in testing. So we're getting the 10 gigabytes a second that we expected. Writes fell off quite a bit. And if there's one piece of work then to do, the writes, we're down there about 7 gigabytes a second on this. And so the aggregate is up there. I didn't get the number on there, but the aggregate's about 13.5. So we do need to work a little bit on the writes. This is, again, coming in clients from 8 nodes against 2 OSSs. So again, still pretty happy with what we're seeing. Still some work to do on the performance as well. Okay, again, didn't have quite as much time to gather up official releases from all the Intel people, but we did get an enormous amount of support from all the Intel folk, and I want to thank them. Maybe I'll just hang it all on our sales support person, Chris Allison, who, through him, many people have helped us both on OmniPath and also on Lustre. So we appreciate all the help they've given. And then there's the contact information for Brian and myself. Nick Nystrom is the principal investigator for the project and is happy to answer any questions. And then some of you may, if you've worked with the PSC, Jason Summerfield's our technology expert, and he's been very close to the system as well. So all of us will be happy to answer any questions that you might have. Okay, thank you.
Thanks, Jerry. So, first of all, congratulations, man.
Thank you, thank you.
Do we have questions?
I almost ran it.
Oh, well, Andreas.
One thing I thought would be worth mentioning is that when you're doing the OBD filter result, you had 17 or something gigabytes a second. Because the ZFS is doing RAID on the host side, you have whatever 25% overhead compared to the 27 gigabytes a second theoretical max throughput of the SAS drives. You're still going to lose something. You could never get up to 27 even if it was perfect, but still awesome numbers.
We I didn't mention, I guess I did forget, we're very much looking forward to any of the AVX support that'll come in. That'll be a huge help because, of course, all the processors are the latest and they'll support them. Thank you. Anything else? Okay.
Anybody else?
Okay, thank you very much.
Thanks a lot, Jerry.